Hello, power electronics experts. In line with the discussion of the thermal modeling of circuits in PLECS environment, I would like to discuss how to use the thermal models that are defined in a newer version of PLECS in an older version of PLECS. An example would be that if you want to download the manufacturer provided thermal models that are given, for example, on PLECS website as well. As you can see, you can download a whole bunch of the predefined thermal models, or maybe you defined it yourself. That would be the example here that we considered in our first example, a tutorial video. Let me show you what I mean by this problem description. So if I open, this is the newer version to the right, newer version of PLECS. And here I can select that IGBT thermal description or the XML file. If I want to do the same from the older version of PLECS, let me go into the thermal description from library. It is already old, is there? Okay, but this is not the same. You see B2, I cannot access that one because that is defined with the newer version of PLECS. And to access it with the older version, we need to modify some parts of it, or we need to describe it completely new. There are two options that I know at this point of recording this video. Either we can describe it completely new, or we adjust the newer version of the XML file to that version of PLECS. To do that, let's start with the new thermal description. So at this point, I cannot select any of them. I deleted even the older version of XML. So let's include new thermal description. I will borrow the names of this to here, and it's in Union. And since I'm going to save this file under the same folder, so I will just call it an old version. Yes, I want to save the changes, and it should be under my PLECS thermal models. So I saved this one. Okay. The similar thing I will do for the diode. So new thermal description. Let's borrow the names as well. I'll call it old. Manufacturer, again Infineon. Close this. Yes, I want to save. And the thermal models library. So here is the folder containing all the thermal models that I have. So I want to modify this one. So let's open it with a notepad. So this is the first modification that I will consider is for the diode. So B2 old. This is what I need to open as well. I would like to separate. So if you look carefully, that this XML description, this is the older one, and this is more or less empty because we do not have any thermal description yet. And to the right, we have the newer version of XML, including all the thermal descriptions. That means for this particular IGBT, we have the turn-on loss. As you can see, this part is for turn-on loss. And we also have the turn off loss here, starting from here to here, conduction losses, etc. The syntax is a little bit different for the both versions. That's why there is this incompatibility issue. You can see the newer one is written with version number 1.3 and the older one is written with version 1.0. And there's some other stuffs, that's why they do not match completely. But what really is interesting for us is this one. So under turn on loss, I will copy this part from current axis all the way up to energy. This one. So I copy this, come to the left description in XML, and from current axis all the way up to energy, I will paste them. So I replace the older versions or the existing syntax that I had. I will just save it. Same I will also do for turn off loss. So let's see, where does the turn off loss start? It is here, turn off loss. So I will again start with the current axis. So if you include the computational method, that will not work because we do not have in the description of older one any computational method. So I will have to start from the current axis, as you can see, and end it up to the line where it starts with the energy. So I need to choose carefully not to make any mistake. So I start from turn off loss here. So I select the current axis all the way up to where the energy is. Copy and paste it here. So Ctrl S to save. So turn off characteristic is now taken over. Now is the time for conduction loss. Let's again start with the current axis and all the way up to voltage drop. Copy this part. We need to find where the conduction loss for the older one is. It starts from here. Okay, from current axis all the way up to voltage drop. Ctrl V. Ctrl S to save. And the last part is for the thermal description. You see the thermal model and then branch type 4-star. So we need to copy this part. Let me check what are the descriptions here for the transient impedance or thermal description. It is type Kawa, but it's by default. We need to modify this. So under thermal model, this is the part we need to modify. So thermal model branch this. So from thermal model to thermal model, everything has to be overwritten, which is exactly this part. I think that's it for this copy and paste. I will close these two files. Now, if everything goes well, we should be able to select the thermal description. Yes, you see under library manager, now the description of IGBT model is visible. To have a quick check of the descriptions. Perfect. So we have the turn on loss, turn off loss, conduction loss, thermal impedances. Let me open from the newer version of PLECS as well for comparison purpose. So this is one. Let me start from turn on loss. So you see, these are exactly the same. It's just a representation, but if you see, it also ends at somewhere. 1200 here. That's turn-off loss. We should see the similar behavior. Conduction loss, similar behavior. Thermal impedance should have exactly the same values. I see 1.314, 1.314. Let's check the second resistor value, 0.0039. Second is 0.0039. It must be the same because we had just copied the values. Very good. And let's also check for the diode. We should be able to select the description. You see, this is already now listed here. Previously there was one diode description, now we have two. We select this. Let's check the value. If you remember, we didn't have any turn-on characteristic or turn-on losses for diode. For turn-off, we didn't do it for... We didn't update the value, so we have to do it for diode. No. So save this. So this is the diode again. Open with Notepad. So I will close the older files and the diode old. Let's open with Notepad again. Let's arrange them side by side. Okay, now the newer description is to the left and the old one, or which has to be updated, is to the left, right, to the right. So let's do the same for turn-on loss from current axis all the way up to energy. There is nothing to change because there is no characteristic of turn-on. For turn-off, we have from current axis all the way to energy. Copy this. Turn-off loss all the way up to energy. Paste. Ctrl S to save. For conduction losses, similarly, I select from current axis to voltage drop. Copy. Come to the older version. Where is the conduction loss? Is here. All the way up to voltage drop. Ctrl V. Ctrl S to save. And the last part should be the thermal description. Now you see to the left we also have an image description, and if you remember from the first tutorial we had a number of screenshots added to the thermal description which cannot be done in the older version. So in older version, if we call the newer version of XML file, it throws an error. That's why we are doing exactly the part of the thermal description that we had to bring back the adaptability. Let's go to the thermal model. So thermal model with branch type to branch, this one. And to the newer one, where is that thermal description? So here, thermal description is here. Let me close these files, and if everything is okay, we should be able to select that and see the changes. So turn-off loss is there. Perfect. Let me open the new version of the XML file as well. So turn-off loss is there. Conduction loss characteristics there. Thermal chain 0.6, 0.6. Yeah, so everything is just fine. So this is the way to use a newer version of, what does it say? Do you want to apply? Yes, I do want to change. The previous one, we also had it already. And as I was saying, this is the way to use the newer version of XML files with thermal descriptions to the older version of PLECS. I think this considerably saves our time, because if we want to do it from the scratch, you saw it took a lot of time to process the data, to look for everything, to screen the complete data sheet. And those one of you who already worked with the older version of PLECS, you know, doing it the primitive way took a lot of time. The new version of PLECS is quite suitable for this type of model building, but in previous times we had to use external softwares to extract or digitize the curves and then export them as CSV or Excel files and bring back into the PLECS versions, which was quite time consuming, and it took a lot of effort to do that. Nowadays we have the newer version of PLECS, and they integrated quite suitable capabilities in the software itself embedded, and this is quite helpful. Let me run the simulation if it's working fine, just to see that. Again, let me close this. So for the older version, I have a block set variant of the software, the same values I have entered to this schematic. So the parameters I need to update for the simulation. So it was TC. Let's take a stiff solver. Variable steps. T step max, and refine factor is refine factor. Apply this. So we have the error. IAC is not defined. Yeah, because we have it is commented. Okay, it's running, but I forgot to measure. We have no probe values. Let's take this diode, or IGBT. Let's just measure the junction temperature. So as you see, it also has a similar curves that we had with the newer version. It was around 136 or something like that. Yes. It starts from 0. Okay, it shouldn't. Let me stop this. TA. This temperature is initially 0, so it should be TA. But this is not the target of this video. Maybe we have some settings that we need to change. It still starts at TA. Okay. Anyway, but this is not the target of this video. What I wanted to describe, I already did. Hopefully it was quite helpful for you, and let me know if you have a better solution for this problem. I would be interested to know that. Thank you for watching.